हेलो दोस्तों, आज की इस वीडियो में हम कार्बोहाइड्रेट के बारे में आपको बताएंगे। कार्बोहाइड्रेट है क्या? द वर्ड कार्बोहाइड्रेट इज डिराइव फ्रॉम देयर जनरल फार्मूला CH2O का whole n that make them seen to be hydrate of water. Carbohydrate and saccharide are closely related. Most abundant carbohydrate are polysaccharide. Most important carbohydrate in the body, glucose. So friend, important of carbohydrate, distributed widely in nature, key intermediate of metabolism, structural component of plants, central to materials of industrial product, paper, fiber, key component of food sources, sugar, flour, vegetables, fiber. Definitions: carbohydrate may be defined as polyhydroxyaldehyde or polyhydroxyketone or compound that yield this derivative on hydrolysis. You can see D-glucose and D-fructose. Glycogen undergo alpha amylase, it gives D-glucose. Function of carbohydrate: energy, intermediate of metabolism, storage form of energy, structural components, fiber, constituent of the nucleotide, detoxification. Some additional term: aldose, a carbohydrate that contains an aldehyde group; ketose, a carbohydrate that contains a ketone; triose, a carbohydrate having 3 carbon; tetrose, a carbohydrate having 4 carbon; aldopentose, a 5 carbon hydrate that contains aldehyde group; ketohexose, a 6 carbon hydrate that contains a ketone group. Friend, classification and nomenclature. Carbohydrates are broadly classified into 3 groups: monosaccharide, oligosaccharide and polysaccharide. Monosaccharide, oligosaccharide and polysaccharide. Functional group: aldoses, example glucose; ketoses, example fructose. Number of carbon atom: triose, tetrose, pentose, hexose, heptose. Disaccharide: maltose, lactose, sucrose. Trisaccharide: raffinose, tetrasaccharide, stachyose. Polysaccharide: homopolysaccharide and heteropolysaccharide. Starch: dextrine, glycogen, cellulose, insulin, hyaluronic acid, heparin, controdietine sulfate and dermatan sulfate and keratin sulfate. Friend, monosaccharide. Mono means one. Monosaccharide are subdivided into different groups depending upon the functional group: aldoses CHO, ketoses CO. Depending upon the number of carbon atom they possess: 3 carbon, triose, tetrose, pentose, hexose and heptose, 7 carbon. Friend, classification of monosaccharide: trioses, tetroses, pentoses, hexoses, heptoses, glyceraldehyde, erythrose, ribose, xylose, glucose, galactose, glucoheptose. Ketoses: dihydroxyacetone, erythronulose, ribulose, xylose, fructose and pseudoheptulose. Friend, trioses: glyceraldehyde, dihydroxyacetone, intermediate of glycolysis, precursor of glycerol. Tetrose: D-erythrose, intermediate of carbohydrate metabolism. Pentose: D-ribose, D-glucose, D-fructose, structural elements of nucleic acid RNA coenzyme, main sugar of the body, converted to glucose and utilized by the body. And D-galactose synthesized in mammary gland to make the lactose of milk. Friend, D-mannose, constituent of glycoprotein, glycolipids. Oligosaccharide contain 2 to 10 monosaccharide unit joined together by a specific bond called glycosidic bond. On hydrolysis they give 2 or 10 molecules of simple sugar unit. They are subdivided into based on the number of monosaccharide unit: disaccharide, trisaccharide, tetrasaccharide, pentasaccharide and so on. Classification of oligosaccharide: disaccharide, maltose, lactose, sucrose, glucose plus glucose, glucose plus galactose, glucose plus fructose in sucrose. Trisaccharide: raffinose, glucose plus fructose plus galactose. Tetrasaccharide: stacylose, galactose plus glucose plus fructose, M pentasaccharide, like that. So polysaccharide contains many more than 10 sugar units. They have high molecular weight and are sparingly soluble in water, cold water. They are also called glycans. They may be either linear or branch in structure. They are not sweetish and do not exhibit any of the properties of aldehyde or ketone group. So you can see the homopolysaccharide, starch, glycogen, dextrin, and heteropolysaccharide, agar, pectins, and glycosaccharides. So structural function relationship of the monosaccharide. You can see the structure of monosaccharide, physical properties and chemical properties. Structure of monosaccharide. Glucose is the most important physiological and biomedical monosaccharide. Glucose in water. It can be represented in the straight chain structure, ring cyclic structure, boat and chair form. You can see the straight chain structure of glucose. Ring cyclic structure, Howard projection, aldehyde alcoholic give hemiacetal, ketone alcohol give hemiketal. Glucose in water. Howard projection formula of glucose. You can see D-glucose converted into alpha D-glycopyranose, Howard structure. This is the pyranose structure, and Fischer structure, alpha D-glucopyranose. You can see the D-fructose, alpha D-fructofuranose, Fischer structure. Chair in both form of D-glucose. Properties of monosaccharide. Isomerism. The compound possesses same molecular formula at different structure are referred to isomer. The phenomenon of existence of isomers is called isomerism. Structural isomerism, same molecular formula but differ in their structure. Aldose ketose isomerism. L-glucose and fructose isomers of each other. They are having same molecular formula C6H12O6 but differ in their structure formula. Aldose ketose isomerisms. Stereoisomerism, same molecular formula structures but differ in their configuration. Asymmetric chiral carbon allow the formation of the stereoisomerism. Types of stereoisomerism of glucose are D and L isomers, optical isomerism, epimers, and enomeres. D and L isomerism enantiomers. You can see the examples: D-glyceraldehyde and L-glyceraldehyde. D and L isomerism enantiomers. D and L isomers are mirror image of each other, and these two forms are called enantiomers. Optical isomerism. Optical activity is the capacity of a substance to rotate the plane polarized light process through it. When light rotates to right, like clockwise direction, that substance is said to be dextrorotatory. When light rotates to the left, anti-clockwise direction, that substance is said to be levorotatory. When equal amount of D and L isomers are present, then mixture is said to be racemic. You can see the instrumentation, light source, polarimeters, polarizers, sample tube containing the organic molecules, movable analyzer, and your eye observer. Epimerism. Epimers are sugar which are differ with each other with respect to single carbon other than anomeric carbon. Galactose and mannose are the epimers of the glucose. They differ from the glucose with the respect of carbon 14 and carbon 2 respectively. You can see the epimers of glucose: D-galactose, D-glucose, and D-mannose. Enomerism. A solution glucose predominantly exists as a closed chain structure. Because of cyclization of sugar, an additional asymmetric carbon center is created at carbon 1, anomeric carbon. This leads to formation of two isomers, namely alpha D-glucopyranose and beta D-glucopyranose. You can see this alpha D and beta D. What is the meaning of mutarotation? It is defined as the change in the specific optical rotation representing interconversion of alpha and beta form of D-glucose to an equilibrium mixture. You can see the alpha converted into beta glucose and equilibrium mixture. So this is, you can see the plus 18.5 plus 50.7 and 112. Now properties of monosaccharide. Some of the important chemical properties of monosaccharide is porphyryl formation, enolization, oxidation, reduction, and oxazone formations. Sugar, when treated with the strong mineral acid like sulfuric acid, hydrochloric acid, nitric acid, they undergo dehydration. loses 3 water molecules to form furfural derivative, and this is the basis for the following reaction: Mollish test and Selivonov's test. So you can see the hydroxyl methyl furfural N color compound. When glucose is kept in alkaline solution for several hours, it undergoes isomerization to form fructose and D-mannose, and this results the formation of common intermediate indiol. The process of shifting of hydrogen atom from one carbon atom to another to produce indiols is known as tautomerization. Friend, you can see the alkaline solution: glucose, fructose and mannose. You can see the reaction mixture. Indiols are good reducing agent and form basis of the reducing properties of the sugar, Benedict's test and Felling's solution test. Copper sulfate, copper 2 plus, indiol, sugar, copper plus and copper hydroxide, Q plus oxide, red precipitate. So when glucose oxidizes under proper condition, the sugar may form monobasic aldonic acid, oxidation with hydrobromous acid, dibasic saccharide acid or alderic acid, oxidation with nitric acid, monobasic uronic acid oxidized by the specific enzymes. The formation of aldonic acid, you can see gluconic acid and glucosaccharic acid. So formation of aldonic acid. Reduction: both aldoses and ketoses may be reduced by enzyme to corresponding polysaccharide alcohol. The sugar alcohol functions mainly as intermediate in the minor pathway of the carbohydrate metabolism. Some of these alcohols are the following: sorbitol, mannitol, dulcitol and ribitol. So D-glucose, D-mannose, D-fructose, D-galactose, D-ribose, D-ributol, D-dulcitol and D-sorbitol, D-mannitol and D-sorbitol. Oxazone formations: only reducing sugar gives this test positive. The presence of free carbonyl aldehyde or ketone group in the molecules is essential for the oxazone formation. Oxazone are yellow crystalline derivatives of the reducing sugar with phenylhydrazine and have a characteristic crystal structure which can be used for identifying and characterization of different sugar having closely similar properties. Friend, oxazone formed from the glucose, fructose and mannose are identical because these are identical in their lower 4 carbon atoms. Non-reducing sugar like sucrose cannot form oxazone due to the absence of a free carbonyl group. The oxazone crystal of some sugars are glucosazone needle shaped, maltosazones sunflower pectoral shape and lactosazone powder puff of the tennis ball shape. Friend, why glucose, fructose and mannose give same type of oxazone? D-glucose, glucoandrazones and oxazones. You can see the structure. D-glucose, D-fructose and D-mannose. So structure needle shaped crystal you can see. Powder puff or tennis ball shaped you can see here. And sunflower petal shaped you can see the structure. Glycosidic formation: when hydroxyl group on the anomeric carbon of a monosaccharide react with the OH group of another carbohydrate or non-carbohydrate leads to the glycosidic formation. The bonds joining the monosaccharide are called glycosidic or glycosyl bond, and there are two types of glycosidic bond: O-glycosidic bond and L-glycosidic bond. O and N-type glycosidic bond, you can see the example: O-type glycosidic bond and N-type glycosidic bond. So physiologically important glycoside: streptomycin, cardiac glycoside, anthracycline glycoside and cubane inhibit sodium potassium ATPase and block the active transport of the sodium. Derivative of monosaccharide: some derivative of monosaccharide are phosphoric acid ester of monosaccharide, amino sugar, glucosamine, deoxy sugar, sugar acid and sugar alcohols. So you can see disugar. So disaccharide consists of two monosaccharide units held by glycosidic bond. They are crystalline, water soluble and sweet taste. They subdivide based on the presence or absence of free reducing group. Reducing disaccharide with free aldehyde or keto group, example maltose and lactose. Non-reducing disaccharide without free aldehyde or ketones like sucrose. Maltose, it consists two molecules of glucose unit. They are linked by 1,4 glycosidic linkage. It is one of the reducing disaccharide which has free functional groups. You can see the structure of maltose. Lactose, you can see the structure of lactose. Sucrose, 1,2, you can see the structure of sucrose. Isomaltose, trihylose. So a lot of compound. Polysaccharides, many sugars. Starch, you can see dextrins, glycogen, cellulose, importance of cellulose, insulin. So my friends, I hope this video will be helpful to you. If you like this type of video, then subscribe my channel. Thanks for watching.